The mean temperature at a given place on Earth is not constant throughout the year. This is attributed to the change of seasons, which is the result of the Earth's orbiting around the Sun, the spherical shape of the Earth, and the axial tilt of our planet. The Earth revolves around the Sun on an elliptical orbit, and it takes 1 year for it to complete one orbit. Since the Earth is spherical in shape, the Sun's rays hit the surface at different angles, resulting in differences in temperature. Moving from the equator towards the poles, the angle of the Sun's rays hitting the Earth gradually shrinks. While at the equator, the angle of the Sun's rays can be as high as 90 degrees, that is, a right angle. At the poles, this angle can be as low as 0 degrees. The higher this angle is, the more strongly the rays heat up the surface and the air. As a result, the rate of warming decreases towards the poles, and the temperature drops as well. However, the Earth's orbit around the Sun and the spherical shape of the planet are not the only reasons why seasons change. The axial tilt of the Earth also contributes to it. If the Earth's axis were perpendicular to the orbital plane, the incoming solar energy would be constant throughout the year at a given point at a certain latitude. In reality, in December, in the region between the Tropic of Cancer and the Arctic Circle, and in June, in the region between the Tropic of Capricorn and the Antarctic Circle, the angle of the Sun's rays is low, and thus the amount of solar energy received is also low. This is winter. In June, in the region between the Tropic of Cancer and the Arctic Circle, and in December, in the region between the Tropic of Capricorn and the Antarctic Circle, the angle of the Sun's rays approaches a right angle, and thus the amount of solar energy received is high. This is summer. Between the two tropics and near the polar regions, the angle of the Sun's rays is relatively